Good afternoon, friends. As you all know, we are doing some numericals from the exercise of the chapter Pressure in Fluids, Concise Physics Class 9 book. And the problem states the diameter of neck and bottom of a bottle are 2 centimeter and 10 centimeter respectively. The bottle is completely filled with water. If the cork in the neck is pressed in with a force of 1.2 kgf, what is the force exerted at the bottom? Okay, so it's a simple Pascal's law problem, and we'll try to get some. Yeah, so this is a kind of bottle, and it's completely filled with water. So like if you got from internet for you to explain, this is completely filled with water, like even this is where the oil is completely filled. It's like total fill. There's not a single space where we are putting air kind of a thing. So this is the total oil kind of, we are thinking this is like, and this is our cork is nothing like made of with wooden kind of a thing. You must have seen in a lot of bottles. It's a very good it don't let the air enter, so it's like total safe kind of a thing. So it's like cork. Now what we are doing is we are trying to press it, like it's like we are putting a force on the cork. We are putting a force on the cork. What's the force? The force here is 1.2. The unit is kgf. So if you spend some time to understand what is this kgf is nothing. It is the amount of force 1.2 kg of anything with mass of 1.2 kg exerts. That means if you want to convert kgf into Newton, it's nothing to do with the problem, but it's better to know. From if you want to just transfer kgf into Newton, like it is 1.5, 1.2, you have to just multiply it with 9.8. That is g. That is g, or acceleration due to gravity, and we get it in Newton. So here we don't require. So a kgf force is nothing but the amount of force exerted, or the weight of 1.2 kg worth of mass. Like if a body is of 1.2 kg, if the mass of the body is 1.2 kg, the amount of weight of the body will be, you can write it 1.2 kgf, or you can just convert it into Newton and do it. So this is just don't get confused on this. So this is just kind of a thing that we need to know. Okay, so I'm just erasing this thing off so that I have more space to finish this problem. Great. So coming back to the problem, sorry, what are the other information that is given? This neck, or this part where I'm putting the arrow, is 2 centimeter. That means the diameter is 2 centimeter. And then we have the bottom, which is also circular. This is exactly 10 centimeter. So if you see the neck of that particular so if I take the cross sectional view of the neck, this will be like this. That is this entered thing. This entered thing is nothing but 2 centimeter. And if you see that of the bottom is like a bigger one, it's like a concentric circle. So the diameter of this total, that is 10 centimeter. Okay, so they have not given directly the area, but they have given in terms of diameter. And we all know, like if you have the diameter, we can really find out the radius, that is half of the diameter, and then we can use the formula of pi r square, that is area of a circle, since it is a circular thing, and then we can find the area of it. So before we really go deep into the finding the area and doing something, first you understand the problem itself. The problem is saying that if you're putting a pressure of 1.2 kgf on the cork, which is directly going on the neck, what will the pressure that you will feel here? What kind of force that you will be feeling out here? So according to Pascal's law, any point, if you see the pressure out here, or pressure out here, or pressure out here, or pressure out here, or pressure out here, all these points here, 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 anywhere, here, anywhere, the pressure is the same. The pressure at any point is same. That is according to Pascal's law, right? So we just have to equate the pressure at this point and pressure at this point. If we just equate it and say this two are equal, then we can find out the force. So let's try doing it. So pressure is equal to force per unit area. We all know that. And if you want to put pressure at neck as Pn, if you try to pressure of neck is like, we can keep the force in kgf. We will get the answer in kgf, 1.2. And to find out the area, what you have to do is like pi into r square. Now if 2 is a diameter, the radius is nothing but 2 by 2, that's 1, that's pi into 1 square. So keep that, pi into 1 square is nothing but pi. Okay, so the pressure at the bottom, like P, B, we don't know the force, so we put the force as F, B, the force that you feel really at the bottom. If you measure the force, you feel that kind of force. And what's the the area? Again, see pi. The diameter is 10 centimeters, so 10 by 2, that's equal to 5 centimeter. So you might ask that why are we not changing the centimeters into meter? Actually speaking, we should change it, but for this problem, since you are equating both this thing equal, even if you are converting this into meters square in terms of multiplying it by 10 to the power minus 4, we can do that. We just multiply this with 10 to the power minus 4, that's from centimeter is also 10 to the power minus 4, and then we are equating. What you are equating, we are saying that okay, Pn equal to Pb. So once we do that, what we get is 1.2 divided by pi into 10 to the power minus 4. This is equal to same as force that you feel at the bottom, pi into 5 square is 25 into 10 to the power minus 4. Now a few things gets cancelled out. This 10 to the minus 4, this 10 to the minus 4 cancels out, so doesn't really make a difference in terms of numerical. This two gets cancels out. So what we get as FB is just, then we just cross multiply this out here. This 25 goes on top in cross multiplications, right? So anything that's changing the side, if it is division it becomes multiplication, if it is subtraction it becomes addition, and so on. So FB is nothing but 1.2 into 25, which is 30, and the unit is kgf. So this is our answer. This, the force that we really feel at the bottom, is nothing but 30 kgf. We have done a multiplication here. See, 25 into 1.2. So if you really can't do this multiplication, you can just do it normally, like 12 into 25, and then do it with that. And there's another easy way of doing it, like I think I should share with you this 2.5 into 25 by let's do it on the page, just the calculation. Let's do it on the page. Okay, it will help you in maths too also if you want to do onto this. This is 1.2 into 25. So 1.2 into 25 is nothing but, what is 1.2? 12 by 10. So the point goes up here into 25, right? So you can really see that if we just divide it by 2, we get it 6 out here. Divide it by 2, get it 5 out here. Now we can cut 5 and this 25 as 5. So what you ultimately get is nothing on below, just 1. 6 into 5 by 1, that is nothing equal to 30. So there are people who, I as during my student life was very scared of this decimal, and then how does it change and where to put the decimal and all those things. There will be some genius guys who will be able to do it just like that, but for most of us, like the one who are really scared in maths, and it's we can do the physics part of it. That's easy for us sometimes, but maths is sometimes very confusing, because you might have learned that in class 4 and class 5 and couldn't have revised that much and you forgot it. So just break it down in the easier thing, like 12 by 10, that is 1.2 is 12 by 10, and then just do simple multiplications and we get the same results. It might take a bit longer, but we're sure that we'll not really do it wrong. So that's how we can find out. So coming back to the problem, the second part of the problem asks, name the law or the principle you have used to find this force. Oh, sorry, I have just answered it before. It was like Pascal's law. It states that pressure anywhere, any of these points, everywhere, the pressure is the same. What a law, right? It's make our life simple, in one sense. Like we can solve this problem very easily, just equating this. In other sense, obviously, the more the laws, the more difficult for us. You have to read more laws. Like maybe when I passed out my ICSE, it was 1998, and there could be a fewer laws than what you've been reading now. So I know it's tougher for you, but in a way it helps us to really solve a lot of real life problems, which if you have some time and if you finish this entire numericals, and then I'll have a session on we'll do an experiment on Pascal's law. I'll post that thing in my YouTube channel, 21st Century Learning. And after that we can do some kind of real life activities, like we have done, might be some activities with some water and something that you might enjoy. Thank you, and if there is any doubt in this problem or any other problems that you might face, just drop it, send the problem to me, take a snapshot, post it on Facebook, and I will solve you within the next 24 hours. Thank you.